Okay, so we have here a humidifier controller. It consists of a Raspberry Pi single board computer running an embedded Linux, and well, there we go. So there's the humidifier. I don't know if you can see the motor, but the motor is in fact spinning. If you can hear that noise, that's the motor spinning. What we'll do here is I'll just kind of breathe on these sensors, try to bring up the humidity. There it goes, and it turns off. So basically, when the humidity is high enough, it turns off. So that's very basic functionality. This board consists of, I know this is out of focus. What we have is a microcontroller here, two humidity sensors. Let me actually unplug that motor. It's getting annoying. We have two humidity and temperature sensors. They're monitored by this microcontroller. These pins on the board here don't actually, you're not going to plug the sensors into the board. They're going to be remote. They'll have cables that plug into the board that plug into the sensors, and the sensors will just be mounted to the cabinet somewhere. I know this looks like a bit of a mess, but essentially there's going to be a small box with this ribbon cable. This will be connected either via HDMI or via this component, rather composite video signal, to probably a touchscreen display of some sort. So you'll have really just kind of power coming in here and a video cable coming out. This will all be inside of a box. You won't see any of this. These terminals are there to make it easy to add your fan. So these two motors, which turn on at different humidity levels, if you open the door, for example, and the humidity starts dropping, one of them will turn on if it drops too much or too rapidly. The other one will turn on also to help bring the humidity back up quickly, so that you have as little fluctuation in your box as possible. There's enough allotments here for 4 things currently, and I know the wiring's a bit of a mess, but the wiring's only a mess just because oh, I think I almost smoked one of the components running the other wire. Anyway, the wiring is only a mess because this is very temporary, so it won't be like this for long. Anyway, so in addition to that, I have actually the lamps, and I just removed power, so I need to put power back on. Bear with me just for a second. Sorry. Yeah, there was a motor that wasn't running. Anyway, so this is the display, which will be on the touch screen. Obviously, that's not what's going to be on there. This is a text version. But if I get my keyboard here, what I can do is, I'm going to do 2 different things here. I'm going to turn on like that, which is a manual. I'm sending it commands basically. So this is connected, the Raspberry Pi, which is a Linux computer, is connected to the board, and the board controls those lights. So that's what I've just done there, is I've typed on the keyboard, and I can turn the lights off, or I can turn the lights on. So the 2 boards communicate to each other. What I'll probably do is, it'll be a combination. So I have a proximity sensor that will go on. The proximity sensor will basically see, if anybody's getting close to the thing, it'll turn the lights on. You can break up these LEDs. These are LED light strips, so they're fairly bright. As you can see, if you're, well, let me hold it up like this. So if this is the inside of your box, and you under cabinet mount these things, so I can hang them like that, they'll actually illuminate pretty well the area. And they can't do like 3 things at once, but here's what I'll do. I'll put this here and try to hold this in such a way that you can see the illumination, and then I will turn them off and you can see how dark it gets. So anyway, basically that's the LED strips. You can, like I said, you can break these every 3 LEDs. So at each one of these copper contact points, you can break it up. You can run wires between them if you want them all to turn on at the same time, so that you don't have LED. You don't have to run a solid LED strip. You can have, like one strip on the top shelf, underneath, where you can't really see the LEDs, but they shine light down. Maybe recess them a little bit, or however you want to do it. then you would, at the end, run wires down to the underside of the next shelf, which would shine down, across and then down on what's below that. And you could do that back and forth, still run them in series. You'd only have lights shining down. They're very flexible, like physically and also architecturally. They actually bend and flex very readily without breaking. So they're very useful for a lot of things, and I think they're going to be perfect for this. They have already 3M adhesive on the back, so it's a very straightforward process. You might have to solder just a little bit because you're going to have to cut them at the end of your shelf, however long your shelf is. Solder some wires, solder some wires onto the next piece, and then run it back, cut it, that kind of thing, until you're done. So it's very straightforward. That's about it. So it's going to fit in a small box. It's going to be about the size of this board here, but a little wider. And so that makes it a little wider than my hand is wide. And so I'm thinking a box maybe about the size of a flat fist, kind of like that. That's pretty much a little bit bigger than a flat fist. So, not a big box, but not a small, tiny box either. There's 4 allotments currently. I have 4 MOSFETs for controlling the LEDs and controlling the motors. I have 2 humidifier fans, 1 dehumidifier fan, also known as a vent fan, fresh air fan inlet, or whatever you want to call it. In the case that something happens and your humidity is raising too fast, we're going to have an outlet to your house, to the outside air, and it's going to be able to, on a schedule, bring in fresh air, circulate it through the cabinet. All these fans, all 3 fans, including these 2, are duty cycle programmable. So you can have them spin at various speeds. You can have a quiet mode where they only spin at half speed, but you spin more of the fans. You can run all 3 fans at the same time, so you're both humidifying and ventilating. You can literally do whatever you want to do. You can accelerate the fans, the lower the humidity gets, to make them go faster and faster. You can program them however you want to program them, and they will function. So as long as you use 12 volt rated fans, this is designed for a 12 volt system. I've got it running actually connected to a car battery, just because that's a ready source of DC, and that's about it. So we have our circuit board, which does all the hard, heavy lifting. This is a very robust solution. This is the one I was talking about, where basically you can't break it. Very, very difficult to break. What we're going to do is we're going to put all the logic for controlling this thing onto this board, because it is so robust, and then we're going to put all the feature-rich stuff on the other board, because that one's not robust, but gives us a lot of flexibility. For example, it has the Ethernet port, it has USB ports. This is currently the way I can also connect to it remotely, because this is a keyboard. This is a wireless NIC. There's a lot of flexibility with this board. Not just the fact that I can talk to the 2 boards, between each other with this ribbon cable, but what's going to happen is this will have the GUI, this will have the front end, this will have your interface, your smartphone, the interface to the web page, whatever you want to have. It'll run the web server, it'll run whatever you want it to run, basically for interface and control remotely, whereas this will do all the heavy lifting. So wherever you're controlling it from, you'll connect to this guy with sort of a client, whether it be your web page on your computer, from work, or from your phone or whatever, or an application on your phone, or whether it be the touch screen that's directly connected to this guy. And when you click Save Settings, what's going to happen is it's going to send over a set of all the settings to this guy, where he will actually write it to his non-erasable memory. And so those settings will be stored permanently in this guy in the case of power loss. So the next time he turns on, this guy will be controlling everything. He'll come back with the last settings that were in there in terms of minimum humidity, maximum humidity, thresholds for turning on and off the fans, whether or not you want to enable or disable the lights, the password for getting in. That's the other thing I have. I didn't set up. I can, although I haven't decided to yet. Where is it? Here it is. Hook this thing up. This uses a really funky protocol, but it runs at 12 volts, so I can run this directly off of the thing. I can power it directly off of this circuit, same as everything else. It also runs off 5 volts, so I could power it off the chip if I wanted to, but I'm not going to. This is a Wigand access control panel. It doesn't do anything special. It has an annoying little beeper thing on it that beeps every time you touch a key. It's capacitive touch. These buttons don't actually move. It's a fairly heavy-duty piece of steel. The intention is that you put this somewhere insecure, and if they rip it off, all they've ripped off are your wires. You still haven't gained access at all. You can put this anywhere, on a wall, on the side, on a box on top, as long as you have the few wire connections you need. And this just gives you a way to input numbers, and those numbers don't have to go to the smart box. Those numbers can go to the dumb box here, and this box will actually control your door latch as well as the interior lighting, and the fan speed motors and your water level, indicator and all that other stuff. So this guy is going to monitor your water level. If it gets low, he'll tell him, and this board is the one that handles actually sending SMS messages or emails telling you your water level is low, etc. This access card reader will directly interface with this robust board, so that if that board goes bad or you lose power, something happens, you don't lose your password, whatever, it doesn't matter what happens to that board. This board is the key. You can still get in. All you have to do is apply power again, and this keypad plus this will let you get in. You can also have an RFID reader that this thing will connect to, where all you have to do is like maybe hold up a card or a token on your key ring, that kind of thing, and it will let you in. There's really no limit to what you can do. Most of the heavy lifting, or all the heavy lifting we possibly can, we're pushing off to this guy, and then all of the intelligent stuff we're leaving up to this guy, so you can have a nice display, touchscreen interface, connectivity to the internet, etc., without loading down this guy too bad, and that's about it. So we're at sort of basic functional level 1